Okay, so I'd like everybody to turn to page 35 in your packets, and we're going to go over vertex form. Now, vertex form is very similar to when we graphed an absolute value function. Now, let's look at this. This is an absolute value function. What makes it an absolute value function? We have a variable underneath in between the absolute value signs. When we graph an absolute value, remember I used to make you hold your hands up in a V because absolute value forms a V. And the way I want you to think to yourself, do you know what the vertex of this particular equation is? Think about it. The way we found the vertex was we looked at the opposite of what was inside with x. So this would be -1. And then we looked at what was outside, and this vertex would be -1, -3. Okay, so if you forgot that, that's a quick review on how to find the vertex. So when we graph an absolute value function, we first graph the vertex, -1, -3. And then we use this as our rise. Whoops, I don't know what just happened there. We use this as our rise over our run. Let's see if I can get this page back. Okay, there we go. Okay, so we start at the vertex and we're going to rise 2 and run 1. So we start at -1, -3. I go up 2 over 1 in both directions. Up 2 over 1, up 2 over 1, up 2 over 1, and up 2 over 1, up 2 over 1, up 2 over 1. And this is how I graph my absolute value function. Okay? So the reason I'm reviewing this is because now when we look at this next form, this is obviously not absolute value. This is my -3. It's not absolute value because this is squared. And this is what we call vertex of a quadratic, the vertex form of a quadratic equation. What makes it quadratic? It's squared. But the way we find the vertex is very similar to what we did with absolute value. You look at what's with the x, you do the opposite, and then whatever's on the outside would be your y. So in this case, my vertex, which I'm going to put in the middle of my chart, is -4, -3. So to graph this, I'm going to graph -4, 1, 2, 3, 4, 1, 2, 3, -4, -3, and a is 2. So I'm going to go over 1 up to a. Well, I'm going to go up over 1 up 1 squared times a. So in this case, over 1 up 2. So over 1 up 2, over 1 up 2. Then I'm going to go over 2 up 2 squared, or 4 times a. In this case, up 8. So over 2 up 1, 2, 3, 4, 5, 6, 7, 8. And this is what my parabola looks like. Now, so the counting method was I went over 1 up 1 squared, or 1 times a, which is 1 squared times 2, which is 2. Or you go over 2 up 2 squared, or 4 times 2, or 8. But if you do not like the counting method, we can always use the table of values. So I can do -3, -2, -5, -6. If I plug in -3, -3 plus 4 is 1. 1 squared is 1 times 2 is 2 minus 3 is -1. Then I can plug in a -2. -2 plus 4 is 2. 2 squared is 4. 2 times 4 is 8 minus 3 is 5. And if you look over here, this is -2, 5. This is -6, 5, and the points match. So with the vertex form, just like with the absolute value, you find the vertex and then you count to plot your other points. So now here you can see, let's move this out of the way. Okay, that vertex form is this. Y equals a x minus h squared plus k, where h, the opposite of what you see with x, k, hk is your vertex. And a tells us how we can rise and run. So if you look, let's make this a little bigger, and we look at this example here, you can see that your vertex is going to be -2, 3, and that because a equals -1, it's going to face downward. So I start at -2, 3, and I go over 1 up 1 squared times a. So that's -1. So I go over 1, down 1, over 1, down 1 in both directions. Over 2 and up 2 squared, or 4 times a, which would be down 4. So I go down 1, 2, 3, 4. And that's how you graph from vertex form. So obviously the advantage of vertex form is when it's in vertex form, it's very easy to graph. So let's turn the page and we're going to practice some graphing. So we will do the first one together, and then I want you to try to do the rest on your own and just check. So for the first one, I'm going to find the vertex. So I'm going to do the opposite of what I see with x. So I see -3, so that means this is going to be 3, 2. So my vertex is 3, 2. So I go over to 1, 2, 3, up 2. Now, a is 1/2. So I go over 1, up 1 times a. So I go over 1, up 1/2 in both directions. I go over 2, up 4 times a, which means 4 times 1/2, which is 2. So I go over 2, up 2. And I go over 3, up 9 times a, so that'd be up 4.5. So 2, 4.5. And I graph it, and it looks like this. Okay, so now I'm going to do the other 3 for you, but if you think you know how to do it, stop the video, do it on your own, and then start the video again and check when I am done. Okay, so if you want to do it on your own, stop the video now. So for the next one, my vertex is going to be -1, 4, -1, 4. So I go to -1, 1, 2, 3, 4. It's going to be facing downward, and a is -2. So I go over 1, down 2, over 2, down 8. And now I'm done. Very quick, right? Okay, let's look at the next one. So first I identify the vertex. And in this case, the vertex is 2, -5. So I go over 2, down 1, 2, 3, 4, 5. And I go over 1, up 2, over 2, up 4 times 2. So 1, 2, 3, 4, 5, 6, 7, 8. And the next one, the vertex is going to be -2, 3. So I go to -2, 1, 2, 3. It's going to be facing downward. This is a -1. So I go over 1, down 1, over 2, down 4, and over 3, down 9. 3, 6, 9. And again, if you still have problems with the counting method, you should really come see me because it makes it much easier. But you can fill out a chart to graph these. Okay? So now we're going to have another video for page 37. So now you can go on to the next video.